I'm Elias Mustafa Dosari from Ittihad National Private School in grade 12 AG, and I'm going to be discussing a physics concept called Coulomb's law. The agenda, which is the topics covered, some general information, real life examples, and 2 problem solving. So Coulomb's law states that the magnitude of the electrical force between 2 charged particles is proportional to the product of their charges and inversely proportional to the square of their separation distance. In summary, it's the like charges repel each other and unlike charges attract. So the history behind it was in 1785, Charles Augustin, which is Coulomb top, used a calibrated torsion balance bottom to measure the force between electrical charges, and the formula is F equal K Q1 Q2 over R2. Q1 and Q2 is the amount of charge in coulombs, R is the distance in meters between the charges, and K is the Coulomb's law constant, which is 8.99 times 109. And some examples is the charged rod, a balloon sticking to a wall, and when the balloon is charged, if the balloon is positively charged, then when the balloon is brought near the wall, it repels the positive charge in the part close to the balloon, and the negative charge get accumulated in that part. And for the mixing substances in the water, when 2 different solutions of ionic substance are mixed, the mobile ion in such solution interact with each other. And here, Coulomb's law describes the interaction between the ions, which is the charged particles. For the first problem solving, we have a picture on the top right, and we define some of the variables. We have the F, Q1, which is the charge of the first body, and Q2, which is the charge of the second body, and R, which is the distance between these two. The problem solving says that the 2 charges are identical, so it means Q1 equals Q2. Since we want the charges, we solve for Q, so we manipulated the equation to look like this, which is just we need the Q. So we enter the numbers, and this equation has 2 possible answers. The charges can both be positive or both negative, and the answer will be the same for the repulsive Coulomb force over a distance of 1 centimeter. So the 2 identical charges of 1 times 10 negative 6 Coulomb separated by 1 centimeter produce a repulsive force of 9. Here negative 6 is in the power. For the second problem solving, we have 2-point charges, and there's a distance separated between them for the 10 centimeter. And the question asked, what is the magnitude of the electric force? And they gave us the constant K. We defined the variables, and so the distance between charge A and B, which is R, the distance A and B equals to 10 centimeter, which equals to 0.1 meter. So here the wanted is the magnitude of electric force. So we bring the formula of Coulomb's law. So the magnitude of electric charge, here we just substituted the number into the formula until we got the number that we wanted, which is 4 times 10 to the power of negative 9n. And thank you for listening.